Mhm. So this is our principle of our group. We all work on the reproducible research side. We rather than focus on the application purposes, we focus on the tool development and bringing those tools to our practitioners, our users, and and improve the reproducible research in the hydrological modeling. And as a product out of that, if you see how the SWAT have been uh, come to existence, so SWAT's success is not just like from last few years. It has been there for since 1992. But there is a lot of history in the background where we had started the data collection in one of our study watersheds in results, where all that data have become critical to develop the EPIC model by Dr. Jimmy Williams in 1984, and that led to SWRRB model, which led to then Dr. Arnold joined in 1990s. He developed this roto model, which was combined. SWRRB and rotomos model was combined, and then we generated the SWAT model from there. Earlier version of SWAT were there 94, 96, 98, and then since 2000, SWAT 2000, we have come into very existence, and people have been supporting us since that time. And after that, Dr. Srinivasan, he became a critical component of the SWAT model, where he brought the GIS interface into the SWAT model. And then now, Dr. Srinivasan and our lab, we are leading our efforts on the HAWQS side. So our HAWQS version 1 was somewhere in early 2008, 2009, but it was specifically at that time for the US EPA only. But over the year, we have improved it a lot. And then we have launched in 2020 HAWQS version 2, and which we will be demonstrating you today. So on the SWAT side, like if I'm think that most of you know about the SWAT model, but SWAT model have been very successful. More than 7,500 peer-reviewed publications are related to the SWAT model, and it has proven to be, it has been utilized more than 100 countries for a lot of different purposes. So considering that kind of success of SWAT model and adoption, we are moving from uh, desktop tools to the web tools. Uh, a basic introduction about the SWAT model, if you don't know about that one. So SWAT stands for Soil and Water and Assessment Tool. It's actually, for the analysis, it's assessment tool, and where we mainly need four main inputs. First is topographic information, so we can delineate the watersheds and then divide that watershed into small computational units, which we call HRU, Hydrologic Response Unit, that Katie will explain you more when we will do the hands-on practice on the HAWQS. So after delineating the watershed and dividing into small computational units, we need to have soil information, land use information, and weather information, so that SWAT can simulate the outputs, such as all the components of water balance, water quality components, and also crop models and others. But however, if you are not a hydrological modeler, you are seeing the model first time, so it may take you a significant time to create a watershed. So that means you have to go to different data sources where you have to collect the information on the topography, such as digital elevation model. Then you have to acquire the soil information, land use information for your particular watershed. And then you have to have expertise on the SWAT model to delineate a watershed, to create the HRU and simulate the response. And then the next is that you also have, along with this input information, you have to have the output information also, so you can read the output files. So this have been a hindrance previously, that agencies were hesitated to adopt the SWAT model because they needed significant expertise, but the staff over there was not that much expert. So from there, we started working on the HAWQS. So HAWQS is mainly a web platform where in the back, HAWQS is just a name for the web platform, which is basically a SWAT model running on a cloud platform. And so what we have done that we have uploaded uh, pre-processed, federally approved, very high quality data sets on the HAWQS web platform. We delineated the watershed. We have the land use, soil information, and everything. So now on this our web platform, if you need to study a watershed, if you have any study area or any lake or anything you want to study, you don't need to create a project by yourself. You can go to the HAWQS website just with a few clicks. Within a few minutes, you will have your watershed project ready, a SWAT model project ready. So that have been our motto these days. So we were the desktop tool. We are developing SWAT and others. We are still improving our SWAT model, SWAT 2012 as well as SWAT Plus. And then on the same time, we are moving to the web-based tools. Currently, we have HAWQS, which is a web platform for SWAT 2012 version. But we are also currently working on HAWQS Plus that may be released in a year or two. That would be a platform for the SWAT Plus model. So HAWQS Plus would be released soon. So as of now, we have HAWQS. Okay. So benefits of HAWQS, as I mentioned, that all the public databases or the associate tool you would require to set up a SWAT model and edit SWAT inputs, everything is already imported into this one. And we have put our efforts. So you don't need to have the expertise on the output, reading the output files. So you can use our user-friendly charts and maps to visualize those outputs. So Katie will show you some example how you can visualize those outputs. Other thing is it is a entirely cloud-based interface. That means that it is running on our local servers here in Temple, Texas. So you don't need to have a very heavy computational power on your machine. You can create a watershed on your phone, tablet, or simple laptop without much of RAM or without any much of the computational power. So everything is on the cloud. Again, no GIS skill is required, so you don't need to delineate any watershed or anything. All the input data sets are there, and these are compatible with other SWAT versions also. Later, if you created a watershed, maybe after 10 years, if you come and you want to do the same thing again. So most of the input data set, well, our approach is to make the things compatible with across all the SWAT versions. Yeah, and then we are not stopping just on the development of the a SWAT model. We are calibrating those models and providing those to the public so that you can directly jump onto the scenario analysis. So you don't need to worry about the calibration of the model. Yeah, this is one of the most significant strength I see that that if you are collaborating with your colleague or with someone at a different location on the same project and you need a same model, you both want to contribute to the same model, so that capability is available on the HAWQS model. So you can share a model, you can work on that model simultaneously. And then one other thing is, as I mentioned on the research reproducibility, if we are we have the chance that you can upload your projects also, you can share that with your team, and you can also share those improved watershed projects with us so that we can incorporate those into the HAWQS model to improve the research reproducibility. So somebody can start a better version of with the better version of that particular watershed when they have the access to your project. Yeah, the same as like we are crowdsourcing a modeler and asking all the practitioners, like for example, there are water districts, irrigation districts, they have been using nowadays HAWQS and other SWAT models. So we are asking them to give us feedbacks, and then uh, using we are improving our HAWQS model day by day according to those feedbacks. Yeah, and yes, it is very efficient. We are, I think, when I say 90%, we are just it may be reducing your more than 99% of time, because you will have now calibrated models ready to be utilized for you. Okay, applications of the host. So as I mentioned that earlier, we were limited that practitioners, they were hesitated to adopt the SWAT model and others because they did not had much of the SWAT expertise. But with the HAWQS, you don't need to have those expertise, no GIS skill, nothing is required. So you can directly jump into the scenario analysis and everything. So people have been using it, like US EPA and other state agencies are using it to for the developing the watershed protection plans, um, uh, generating some outputs for the different BMP or other scenarios, and see how they can improve their local water sources. So those kind of applications are there. In all the case, mostly are currently on the water quantity and quality side, not much on the crop modeling or other side like ET and others. So, but that's the future. We are improving folks in that direction also. So this is a list of all the federally approved data sets are available on the HAWQS as of now. So for example, we provide the PRISM data, which is graded data, from 1981 to 2020 available as of now. It will be soon available up to 24. And also with the next set, the same way we have NLCD and the data layers already incorporated for the land use. Surgo and StatsGo, a combination of both, is available for the soil, and other, like we have the dam information, ponds or pothole information also. So if somebody wants to work in that direction, so they can utilize this information also. Then at what scales we are providing these watersheds. So as you will see when Caddy demonstrate, so there are different tiers we provide. So you can create a watershed project at HAWQS scale. Like for example, if you have you want to create a project for the Missouri Basin, you can create it at HAWQS scale or HAWQ10 scale, HAWQ12 scale. And recently we have created the HAWQ14 scale HAWQ14 small watersheds with the average area of 22 square kilometer and uh, 8 square mile. So for example, wherever your outlet is, so if you click on your outlet, you will have your watershed ready. If you select the HAWQ12, for example, here, so each of this red boundary is that red boundary? Yeah, red boundary is a boundary for the HAWQ12 out of that. Okay. If you have any question on this one, please let me know. Okay. So this is another quote I like that says that it is from one of the previous Google CEO, and they have said that best inventions are never finished. Great inventors keep working on those innovations and keep improving those. So with that one, we also after the HAWQS success, we thought, okay, rather than just providing the watershed projects, we should provide more information, more uh, like the calibrated watershed to our users so they can directly use it for the scenario analysis. So first we started with all the USGS gauges which are available across the US. So there are around 11,000 of US gauges, and out of those, uh, there was significant data was available for 5,800 gauges. So our first step was to calibrate the HAWQS watersheds at HAWQ12 scale. for all those gauges, and we could calibrate around 4,113 gauges out of that. So the green color here shows all those calibrated gauges. Then uh, I conducted a study with in collaboration with KT and Dr. Srinivasan. So where we where we implemented a machine learning approach to transfer the knowledge from the calibrated watersheds to the uh, gauged watersheds to the gauged to ungauged watersheds. So all this orange color shows that where the parameters are transferred, the accuracy was checked, and they the this parameter calibration parameter transfer approach showed very high accuracy, like each region that was tested for the each HAWQ2 region, and we found the accuracy ranging between 85% to 95%. So we adopted the approach to transfer the information from the gauged watershed to ungauged watershed. And then as we go to the west, we did not have much data to implement that machine learning approaches. So that's where we started using the OpenET data sets to calibrate those watersheds. So we have we have calibrated the entire for the entire country at HAWQS scale using the OpenET. But as of now, we have data available on the HAWQS platform up to region 11 only. So we are a little bit improving our data set, and it will be soon available for the entire US. Okay, so overall, the key takeaways from this presentation is that HAWQS is there, which we have developed to simplify the SWAT modeling. It is a very user-friendly web interface. Katie will show you, and you will see how user-friendly it is. It is available on the external server, so you don't need to worry about your computational powers on your end, and a high quality input data set, which is always the first step to reduce the uncertainty in the modeling practices. So we have already taken care of that one. High quality input data sets are available. So each input data set have been gone through a lot of verification before implementing onto the host. And then we are providing you to on the visualization side, output visualization side. So you can create a lot of maps and charts and directly utilize that into your reports or into your uh, uh, manuscripts and others, and a significant reduction of time in that one. And there are another other things also, that one of thing is that we are we are targeting to provide the outputs formatted into a format that is acceptable for the other models. For example, uh, some many of our practitioners wanted to use SWAT model outputs for their models like SQL W2 or HAWQS or others. So we are converting the SWAT model outputs uh, directly. So you can download those outputs and directly implement that into your model. So uh, you don't need to worry about you don't need to learn the SWAT model and how to create those outputs and again the format into your model uh, format, so you can utilize those directly outputs into your model. And then yes, we have provided you the hydrological calibrated uh, watersheds as of now up to region 11, but soon it will be available for the entire US. So when we started working on HAWQS, when we started providing um, created watershed to our users. So somebody asked us, well, that would not that impact your collaborations? So why will people would need you? So currently they need us because of our expertise on the modeling. But with the HAWQS, they can be independent. So they asked us, will is it a beneficial approach to go for? So we took that risk, but yeah, it has increased our collaboration up to threefold. Many agencies have seen the power of HAWQS and how efficient it could be for them. And they have been adopting it. For example, in Texas, a few water districts in Texas, TRWD, Terran Regional Water, Lower Colorado, they have adopted it and they are using for their watershed protection plan, and others, same for the Oklahoma, South Carolina, and other states. And then we are also going the international, South Africa, Brazil, India, Ukraine, that is already available, that is already developed HAWQS. So we have currently for the 7 countries, and we are recently working with South Korea and Spain to generate the same for those countries as well. So with that, I will end this presentation and ask you if you have any question, and later Katie will take you to a demonstration on the HAWQS.